Hey kids, Flexing Teacher Weber here. I hope you're having a good day. We have been studying three-dimensional objects. We have looked at the cube. We have looked at the rectangular prism. Yesterday, we did a review of triangles in order for what we're going to do today. Today, we're going to look at the triangular prism. Now, a triangular prism is what you see here. It's made up of rectangles and triangles. Some common examples of this would be, this looks like the classic version of a tent, even though I don't know how many tents actually look like this anymore. And it also looks like the classic Toblerone chocolate bar, one of the tastiest things ever. And you can get these things the size of clubs, these Toblerone chocolate bars. They're pretty awesome. Now, you can see here it's made up of triangles and rectangles. There's a triangle. There's a triangle at the back. And there's a rectangle at the bottom. And there's actually a rectangle here on one side and here as well. So, we are going to do two things with these objects. We are going to sketch the net and calculate the surface area. So, when I sketch the net of a three-dimensional object, I always like to start with the bottom. And you can see here I'm tracing the bottom. The bottom is a rectangle. The reason it doesn't look like a rectangle is because we're showing the three-dimensionalness of the shape. And that sort of distorts the view. But you can see I've got a rectangle here, and it's a rectangle that's 20 by 16. 16 is the width, 20 is the length. So for my net, I'm going to draw a rectangle. I'm going to draw it like this. That'll be my 16. And that'll be my 20. So that distance is 20, that's 16. I'm going to call that BO for the bottom. That's not 16. The 16, of course, goes down here. So there's your 20, and there's your 16, and we'll call it BO for the bottom. Okay, so there's our bottom. Now, I'm going to do the front. Now, the front connects to the bottom right here. It connects to that width of 16, and you can see the front is a triangle, right? It's a triangle that has a height of 8, and that triangle, we could connect that to the bottom, where the bottom is 16 centimeters. So I'm going to go back to my net, and where the bottom is 16 centimeters, I'm going to draw my triangle. And I'm going to label that height of 8. And I can call that, since it was closest to us, I'll call that FR for the front. Now it logically makes sense now, since we did the front. Probably makes sense now to do the back, because the back is exactly the same as the front, right? This triangle at the back has to match that triangle at the front. So there's the triangle at the back. And it's connected to the bottom at the other end of the rectangle. So I'm going to go over here, and I'm going to draw my triangle. Oh, it's going to capture this word net. That's okay. There's my triangle. That distance is 16, and we'll draw the height down of 8. And there's my net so far. I've got one of the rectangles and two of the triangles. Now, I think the next logical place to go would be to do the two rectangles on the side. So you can see a rectangle here, and you can see a rectangle over here on the other side. Now what I'm going to do is I'm going to keep it connected at side 20, and I'm going to fold it out. The dimensions of this rectangle are 20 by 10. So I'll draw that over here. Draw this rectangle out, like so. Now that distance we already know is 20, and this distance is 10. And then we have the rectangle on the other side. That distance that I'm outlining now will be 20 because it matches the other side of this rectangle. And then this distance will be 10, the width will be 10, because you can see here this distance is 10 and there's a little marker indicating that they're the same. So this is actually what's called an isosceles triangle. So for our other rectangle on the side, we have 20 by 10 as well. So it matches both sides are the same. So I'm going to go to my net and I'm going to draw the same rectangle, 20 by 10. Something that looks like that. 10, and then I'm going to call both of these the sides. And there's one version of the net of this triangular prism. Now, as we've learned before, there are many different ways to draw this, but I always like to start with the bottom and work from there and like unfold it like a box. So now what we have 3 rectangles. The bottom one is different than the 2 sides, and then we have 2 triangles. We're ready to calculate our surface area now. So I think we should do this by labeling things. Let's calculate our rectangles first. Now we know the area of a rectangle is area equals length times width. So let's do our bottom rectangle first. Our bottom rectangle is 20 by 16. So area equals 20 times 16. Area equals, well, I know 2 times 16 is 32. Tack on the 0. That's going to be 320 centimeters squared for the first bottom rectangle, this guy in the middle. Now, let's do the 2 side rectangles. Their dimensions are 20 by 10, and there are 2 of them. Oops, went the wrong way. So I'll just do this below. I'll write area equals length times width. Area equals 20 times 10. And that's 200 for one of those rectangles, centimeters squared. But remember, went too far again. Remember, we have 2 rectangles of the same size there. So let's double the size of this. Let's times this by 2. I'll just do this so I save a bit of space here. I'll leave the units off right now, and I'll do 200 times 2. So that means the area of those 2 side rectangles are 400 centimeters squared. So we've calculated the area of all of the rectangles. Now it's time to do the area of the triangles, which we learned about yesterday. So over here, I'm going to write triangles. And we know the math equation for area of a triangle is area equals base times height divided by 2. So let's take a look at our triangles. We'll start with one of them. They're both the same, right? So the base of the triangle is 16, the height is 8. So we're going to do area equals 16 times 8 divide by 2. And we can actually divide by 2 first. Pick one of the numbers to divide by 2. I'm going to do, what makes a lot of sense here is to do 16 divided by 2 gives me 8. So all I've got to do is 8 times 8 is 64 centimeters squared. That's the area of one triangle. But remember, we have 2 triangles that are the same. So we'll take that 64 centimeters squared and we'll double it because we have 2 triangles that are the same. We'll double that and we get area equals 128 centimeters squared. And now you've calculated the area of the bottom rectangle, the area of the 2 side rectangles, and the area of the 2 triangles. And now all you need to do to get the total is add them up. So I'm going to label this total. And I'm going to do 320 plus 400 plus 128. Add up those measurements, and I get 848 centimeters squared. That's our total area for that triangular prism. And then if it was a Toblerone chocolate bar, you would know how much wrapping would need to go around that Toblerone. Except the wrapping wouldn't be on there very long, right? You'd be ripping that wrapping off and drilling that Toblerone into your gut as quickly as you could, because those things are tasty. I hope that helps. That's the first video on calculating surface area of a triangular prism. We're going to do another one as well, but I hope that helps. That's all for now. Flexing Teacher Weber out.